Okay, so now let's go about talking or discussing more about the programmer's model, right? So let's discuss more about this. Now we mentioned that the programmer's model is essentially an interface or like a mental imagery of the CPU that a programmer can reason based on, right? And reason about what? Reason about the CPU, right? Okay, so what all does the programmer's model have? To understand that, we need to kind of, understand what a CPU is and what it does. So the CPU will do data processing. That's like what it does, right? And then the other thing is that, data processing definitely, and to do the data processing, there is going to be like a, control unit, let's say, or there's some entity that controls it, right? Okay. So you would have come across terms like ALU, control unit, so on and so forth. Now, there is something special about the ARM classes of CPUs. These are based on something called the RISC architecture. Right? It's called the reduced instruction set computer architecture and so on and so forth. But the idea here is that you always load the data from, okay, let me just draw here. So let's say this is the CPU and this is the memory. So the idea is that you always load the data from memory to CPU first, process it, and once the processing is done, you take that data and put it back into the memory. So this is called the load operation and this is called the store operation. And so the RISC architecture essentially is the load store architecture. That we have to remember as we go forward in this series, that we are talking about a CPU that's based on RISC architecture, and RISC architecture essentially means load and store. Load the data into the CPU, process it, and send it back. Now, that said, the question is, where is the data loaded? And the answer to that is that internal to the CPU, there are something called registers, right? So these are called the GPR or general purpose registers, right? So the data is essentially, from memory fetched into the registers here, let's say different registers, and then the ALU kind of, or the internal circuitry, the math circuitry, operates on these two registers and puts the answer back into some other register, and from there you kind of send it towards the memory, right? So this was the load operation, this was the store operation, the load store architecture. Now, what is a register? So if you have heard of, all right, so if you have heard of the D flip-flop, you load some data here, and then that stays kind of, lashed, or that stays kind of logged within the D flip-flop. So that's like one bit being stored. And if you have many such D flip-flops, storing, in our case, let's say, 64-bit, then it's called a 64-bit register. And once you have many such registers, that's called a register bank. So a CPU then essentially, an ARM CPU, can be thought of as a collection of register banks. One of the register banks is called the general purpose registers, and these are used to fetch the data from the memory, do computations on those, and store them back into the memory. And there is another set of registers which are called configuration, right? And then there is another set of registers that are called the status. And typically, configuration and status can be clubbed together as one terminology and say this one bank called CFRs, configuration and status registers, right? I'll just write it here, CFRs. All right, so why are we talking about all of this again? Because programmer's model. So we are saying that a programmer can imagine a CPU to be just collection of registers, few registers to process, keep unprocessed and processed data, few registers to set the configuration of the CPU. Configurations can be things like, privileges, modes, then execution levels, so on and so forth. And these are all terms that, we'll discuss in future videos. But configuration is to kind of configure the features of that CPU. And then there are other registers called the status registers that report back as to what the CPU is doing. For example, did the addition of two numbers lead to an overflow? Did subtraction of two numbers lead to like a negative number? Did it lead to like a zero being generated? So all of that is recorded in the status registers. So as seen from the programmer's view, and you just have to brain tattoo this, as seen from the programmer's perspective, a CPU is just collection of registers. And around those registers, the CPU behave in certain ways. So the behaviors in the registers is what we want to know about, right? You don't have to bother about, oh, okay, how is the addition implemented? Oh, okay, how is the CPU, actually controlling the different wires or different circuitry to get the job done? We don't have to discuss any of that, or we don't have to remember or focus on any of that. The implementation, we can forget about it. What we only have to remember is there are certain set of registers that change as the CPU does its job, right? And that then is kind of called the programmer's model, and that is what we'll focus on.